leaving space on either side of each of my fractions. That way we can go ahead and put in the information that we need to make it a common denominator. So this becomes 8 over y minus 3 stays the same, plus 2y minus 5 over y minus 9, y minus 3. My goal is to make both of my denominators the same. I already recognize that they each have a y minus 3 in them. So looking at the left side, what do I need to put into that denominator to make it match the other side? Y minus 9. What we do to the bottom, we also have to do to the top. What do I need to multiply into my right fraction to make them the same denominator? Nothing. It's already perfect. Because now, once I multiplied the y minus 9 into the left, they match. So I'm going to distribute that y minus 9 into my numerator, and then we will continue simplifying from there. So when I do, I get, yeah, we'll do it like that. 8 times y minus 9 over y minus 9, y minus 3, plus 2y minus 5 over y minus 9, y minus 3. And then what do I do from here? Combine the numerators with this operation. I'm also going to distribute this 8 in, and then we'll combine like terms from there as well. So this becomes 8y minus 72 plus 2y minus 5 over that common denominator y minus 9, y minus 3. And then we just combine like terms. So I can put the 8y and the 2y together, and I can put the negative 72 and the negative 5 together. And I get 10y minus 77 over y minus 9, y minus 3. How do we feel about that? Okay-ish?
Is there actually any job that would require this?
Yeah.
Being a math.
I don't understand
Being a math
why.
teacher.
This is it.
Being a math
It's
professor.
for your cognitive thinking abilities.
It's-
It is all brain practice.
You can just do brain teasers all day.
Okay. How do we feel about this type of problem? Okay. I would actually like a 1 to 5 based off of like what you saw in the homework, how comfortable you felt with that and doing these examples. So 1 to 5, how do you feel about this type of thing? So I'm seeing a lot of 3s and aboves, which is really good. So what I'm going to do is I'm going to move into a different type of problem because I think it's also on your homework. If not, it's still a good problem to do. And then I'm going to give you homework time. Okay?
Wait, is that the only other example besides the extra one?
Well, this will be the only one. I'm probably going to do 2 more and then we're done. That's my plan. So on these next couple examples, I would like to simplify it, which means I'm actually combining this lesson and the lesson we did before all into one. So the problem we have is 1 plus 1 over x all over 1 minus x over y. This is the first one. Who has an idea of where we're going to
Cancels out.
start? Nope.
I wish. Look the exact.
What do you mean the ones?
Think so.
They can't cancel either, no.
Using our calculator.
Although that is something a lot of people would try to do.
Wait, would you put it like over 1 and then the bottom one over 1 and then you just divide it like that?
Well, I can't do that because then I have a fraction and a fraction and a fraction and a fraction,
No,
and that's
because
crazy.
1 plus 1 over
That's
x,
it.
you try to get a common denominator of x.
So I'm going to individually try to simplify my numerator and denominator. In the numerator, I'm going to create a common denominator of x and simplify. In the denominator, I'm going to create a common denominator of y and simplify. and then we'll divide a fraction over a fraction, which we did a couple of days ago. So in the numerator, I know in order to put these two fractions together, they both have to have a denominator of x. So what is a way I could re-represent 1 with a denominator of x? In order for a fraction to go to a whole number, what has to be true about the numerator and the denominator? They have to be the same. So 1 is the same as x over x. So I get x over x plus 1 over x in my numerator. Same concept in the denominator. I need to turn 1 into something with the bottom value of y. So I'm going to rewrite it as y over y minus x over y. They now have the same denominator respectively, so I can simplify them by making the numerator one fraction and the denominator one fraction. So I get x plus 1 over x in my numerator, and I get y minus x over y in my denominator. Anybody confused so far? Anybody super duper confused so far? What will I do from here to simplify this as far as I can possibly go? We did it 2 days, or last lesson. What do we do at Sam? We're doing a fraction divided by a fraction. So how do I change that to something I can actually compute with Sam? Not Sam, sorry, Madison. Okay.
And then y minus x over y, and then start finding like terms.
So we can't find like terms until we turn into a multiplication problem. So how do I turn a division of fractions into a multiplication? So we flip the bottom fraction and multiply it into the top. So this becomes x plus 1 over x times y over y minus x. So I flipped my bottom fraction and multiplied it into the top. Everybody really take a look at what I did. And then my last step is to multiply the numerators together and multiply the denominators together and see if something cancels out. It's not going to. This will not simplify any further, but that doesn't mean I can't try. So if I multiply this together, the y is going to multiply into both the x and the 1, and the x on the bottom is going to multiply into both the y and the x. So this becomes xy plus y over xy minus x squared. You also could have left it as y times the quantity x plus 1 over x times the quantity y minus x if you recognized it wasn't going to simplify any further. How do we feel about this one? A little bit better than the last one or no? Worse?
I'm not too,
Yeah, it
I don't
does.
really like
My
this
brain
very
wouldn't
simple.
be able to think of it on my own. Like I understand what you're doing, but I wouldn't be able to do it on my own.
Shane?
Where did you get the excess?
I changed 1 into a fraction that had the denominator x, so it became x over x. And I changed this 1, so it had a denominator of y, so it became y over y. Huh? Well, for 1, the top and bottom have to be the same. If I had like 2, then it would be 2x over x. It pretty much always works for any whole number, just the number in front on top. Yeah. Yeah. But you pretty much always have a 1 in there if you are required to do something like that.
How did you get the x plus y over y minus x squared?
Oh, I distributed this y into both of those, and I distributed this x into both of these because I was multiplying them together. But you could have left it like this as one fraction. That would have been acceptable. I just prefer the look of the second option. We are gonna do another one of these before I turn you loose on your homework. And it's gonna be mostly you doing it. So I'm calling on Alex specifically. Got it. Okay, are we done writing this example? Anybody still writing it? Because I don't want to move on if you are. Yeah, it was a push.
David already joined. Why is there another?
David online today?
He was. I heard the clean like a minute after she shut the door.
Oh, that's Cadence. Oh, I did not know that was Cadence. Yeah, okay. Sorry, Cadence, honey. I almost kicked you out of the meeting. That was fun.
It's like, oh. Sorry if you would have just texted me and told me to like set up my phone.
Okay, this will be the last one that we do. One minus y over x over 1 plus y plus 1, sorry, 1 over y plus 1 over x. Miranda, where are we going to start? You don't know. Okay, so when we have a fraction over a fraction, we treat the top and bottom independently. So if I'm just looking at 1 minus y over x, what's the only way I can simplify that? Make it an x over x. Perfect.
X divided by x.
X divided by x equals 1. Top and bottom are the same. So I just re-represented y, well not y, 1 as a fraction with the denominator of x. What's different about the bottom of this problem? I don't have a 1 there, so I'm actually going to have to find a common denominator between the two of these. So x is going to multiply into this one, and y is going to multiply into this one. Yes. That way I create a common denominator of xy on both of those denominator fractions. So when I do, I get x over xy plus y over xy. They are two different fractions with the same denominator, so I can rewrite them as one fraction. Same with the top, so I have x minus y over x all over x plus y over xy. I have one fraction on the top and I have a fraction on the bottom, which means I'm ready to do what? Divide, which actually means I do what with the bottom fraction? Flip it and multiply it into the top. So I have x minus y over x times xy over x plus y. Just like on the previous problem, since this is one term, it's going to multiply into both. Since this is one term, it's going to multiply into both, and I'm going to see what happens from there. Yes, ma'am. Yeah, x, y, the whole thing is going to multiply into both. Yeah. Yes, you can get x squared y minus xy squared over x squared plus xy. Right? What do I now notice about every single one of these terms? They all have at least one x in them, which means I can simplify by taking one x out of all of them, or dividing it out of all of them. Which leaves me with xy minus y squared over x plus y.
That's it.
That's it. Because I could cancel one singular x out of all four of those terms. So if you can, you should. I know this is awful, awful, awful.
Awfully fun.
Yes, way to turn that around, Alex. But this is it. All the rest of the class is homework time. And if you have some problems that you want me to check, I'm more than happy to do so.
How do you know what?
What, Shane?
How do you know what X means?
All of that. See, I can only cancel if it's in all of my terms. And so this had an x squared, which means it had two x's. This had one, this had two, and this had one.
Okay, so whatever one that doesn't have the square.
Well, I took one out of all of them. So when I took one out of x squared, the 2 went away. When I took an x out of here, the x went away. When I took one out of here, the 2 went away, and I was left with 1, and then that one left. Yeah. So I just took one out of all of them, and what's left is that answer.
I got it.